Hi, in this video I'm going to solve another example of a piecewise function with a limit with a piecewise function. So here it's my limit I'm going to define here, and over here we have our f of x, which is divided in three pieces, these three. Now I already draw this nice line here on the left so you can see how it will look like these intervals in a line. But now I'm adding a different question, another question. It's this one here. Is f of x continuous at x equal to 2? Well, let's see how we can work this through. But first I'm going to focus on this one, the limit when x approaches 2, and then let's get to that. And after that we'll get to this, answering this question. Well, let's see. First I have to see, well, this limit of f of x when x approaches to 2, well, the 2, we have this numbering here in the center of a line, and from the left of the 2 we have this function 2 times x minus 3, and on the right we have this negative x plus 3. Now notice something here, the x, when we have x equal to 2, the function f of x, we have a value of 8 in here, but that's only when x is exactly equal to 2. For the purposes of getting a limit, this one, it's completely useless for the purposes of finding a limit. Okay, that's only for the purposes of finding a limit. So for the purposes of this limit, we got to ask ourselves, what happens when I get really close to this number 2, first from the left and then from the right? So in other words, I have to find out the limit for f of x when x approaches to 2 from the left, and as well I have to find first the limit for f of x when x approaches to 2 from the right. Now let's see, let's solve the first one through the limit from the left. This limit will be when x approaches 2 from the left, f of x, in this case f of x is behaving as 2 times x minus 3. I'm going to substitute right away here, 2 times x minus 3, using parentheses here, and we can notice we do not have an undefined here, so I'm going to substitute right away. It will be 2 times 2 minus 3, and here we got it with 4 minus 3 will be 1, and that will be the limit for f of x when x approaches to 2 from the left. Now let's get to the limit from the 2 approaching to number 2 from the right. So this would be the limit when x approaches 2 from the right. In this case the f of x is good for negative x plus 3. So I'm getting here the negative x plus 3. I'm going to substitute here right away. We do not have an undefined. This would be again a number 1. So this is number 1 would be the limit for f of x when x approaches 2 from the right. Now as they have the same value, we can just assume that the limit for f of x when x approaches to 2, that is the general limit, would be equal to 1 here. Now there we just got nicely done with the first question here, this one. But now we have to look for this other question. The limit, the question is f of x continuous at x equal to 2? Now what is continuous in mathematics? You know, in mathematics the definition for continuity, as we have talked in previous videos, would be looking something like this. When x approaches to a, for this limit of f of x would be equal to a value of L, and again also this value, if you evaluate the function with the value of a, you must have the same value of L as a result. So in the purposes of this example, I'm going to write here a different color. I'm going to use here a bit overwriting here for the purposes of this example here. Now in this case the limit of f of x when x approaches to 2 the limit is equal to 1. And here the limit when what is f of 2 in this case? F of 2, it's defined in here as 8. So as these two are different, then the answer for this question is f of x continuous at x equal to 2 would be a no. It's not continuous at x equal to 2. Now, if you would like to see it through a graph, I'm going to try my best to draw a graph here quickly. You will have something like this. Imagine this graph, and here is the number 2. And the number 2, you have a definition such as 8, which is here is a whole circle here in the number 8. The limit from the left of the 2 will be a line that goes until here. Let's say here is a 1 and crosses. We have here an open circle, and we will draw it to here. This line will go all the way to negative infinite. Now, the other line, which is this one, negative x plus 3, would be starting out from here, and we continue something like this. Oh no, this is a negative, so it should be going like this. This would be the negative x plus 3, and the other one would be our 2 times x minus 3. As you can see here, we have a hole here. This is, just so you can remember, this is a type of discontinuity that is usually called as a removable discontinuity. But I think now you'll be able to notice to find it out in a piecewise function using algebra, just as we did here. Well, basically that would be all with this video.